Hi everyone. In today's video, we are going to discuss how to solve this differential equation. This differential equation is of the type reducible to exact differential equation. With the help of this example, we will see how to solve such problems. Okay, but actually before starting this example, we will discuss or we will recall what is exact differential equation and how to solve, right? So see, when you have differential equation of this type, m dx plus n dy is equal to 0. So when you have differential equation of this type where m and n both are functions of x and y, you can easily see this differential equation is of the same type. This is a multiple of dx, so this is our m, and this is multiple of dy, that is our n. So m and n are basically functions of x and y. When we say it is an exact differential equation, if partial derivative of m with respect to y is same as partial derivative of n with respect to x. If these two partial derivatives are equal, we say the differential equation is exact, otherwise we say it is non-exact. So let us check whether the given differential equation is exact or not. So let me note down m first. M. What is m? The multiple of dx is m. So y 1 plus xy plus x square y square. So what will I do? I will solve the bracket. It is better to take the product. Okay, y into 1 y into this xy square, y into this term x square y square into y cube, right? N is nothing but multiple of dy, which is x 1 minus xy plus x square y square. So let us simplify it. Let us solve the bracket. X into 1x minus x into x square y plus x into x square x cube y square. Okay, so in this way I found out what is m, what is n. Let us find the partial derivatives and check whether both of them are same or not. Now, partial derivative of m with respect to y, right? So what is my m? So we have to find its partial derivative with respect to y. Let me write the m here. You can easily see how many terms are there. 3 terms are there. Addition is there. We can take separate derivatives. So derivative of y, derivative of this xy square, and derivative of x square y cube. See, here we are differentiating with respect to y. So that's why x is constant and all functions of x is also constant. So let us take constants outside. But see, in the first term, we are finding derivative of y with respect to y, which is 1. X is constant. You can take it outside. Here x square is constant since we are differentiating with respect to y. Okay, so in this way I took the constants outside. So let us find the derivatives. 1 plus x. So let me write the formula here. Okay, so you can easily find the derivatives. The formula is derivative of x raised to n is n x raised to n minus 1. The formula says if you have any power of x, what we do? We write the power first and we reduce the power by 1. I will do the same thing here. What is power here? 2. We should write it here. And we reduce the power by 1. So that means y raised to 1 x square. Same formula is applicable for this derivative, right? Power is 3. I should write it here. And we reduce the power by 1. So square only. So let me write in a simple way. 1 plus this 2xy. Better to write in this way. 3 is constant, x square y square. Okay, so finally we got the derivative with respect to derivative of m with respect to y. So let us go for the second derivative also. Now, derivative of n with respect to x. Okay, let us find derivative of n. Where is my n? This is my n. I should put it here as it is x minus x square y plus x cube y square, right? Yes. So you can see 3 terms are there, first, second, third. They are separated by plus and minus signs. So in case of derivative, if you have plus and minus signs, we can take separate derivatives. So derivative of x minus derivative of x square y plus derivative of x cube y square. Okay, so derivative of x with respect to x is 1. Here we are differentiating with respect to x. It means y is constant and all functions of y are also constant since we are differentiating with respect to x. So we can take them outside. So let us take this y outside. We will have derivative of x square, and here y square is constant. You can take it outside. You have x cube. Okay, so actually I need some more space, so let me remove this part. Okay, just keep in mind we need to check these two partial derivatives are same or not. If same, then we say it is exact, and it has very simple method to find its solution. But say if both of them are different, then we say the given differential equation is non-exact. Okay, and we need to put some extra efforts to find its solution, but we will do it, don't worry. Okay, see, this is equal to 1 minus y. See, the same formula is applicable here which I told you just now, just 2 minutes before. Okay, so derivative of x raised to n is n x raised to n minus 1. This formula is quite simple. Whatever the power, in power if you have n, you should write it here, and we reduce the power by 1. What is power? 2. So 2, and we reduce it by 1. So 1 y square. What is the power? 3. 3 I should write, and we reduce the power by 1. That means 2. So 1 minus, let me write in the proper way, 2xy. X has power 1, so no need to write. Plus 3 x square y square, right? I got it. So I got the del by n by del by x, and as well as we calculated del by n by del by y. Tell me both of them are same or not? No, getting no. So here we have a plus sign, here we have a minus sign. So that's why these partial derivatives are not equal. So we can say it is non-exact. So let me clearly mention. So here del by m by del by y is not equal to del by n by del by x. Therefore, given differential equation is non-exact. That means we cannot find its solution directly using the formula. It is non-exact. So first task is to convert this non-exact differential equation into exact differential equation. After converting, we will solve it. But now the question is how to convert. So we can convert it with the help of integrating factor, right? Integrating factor. So obviously next question will be in your mind, how to find integrating factor. So actually there are 4 different rules of finding integrating factor. So let us see which rule is applicable here. Okay, so I will tell you all 4 rules. The first rule is del by m by del by y minus del by n by del by x upon n is function of x. Okay, that means what we do, we find the difference between these two partial derivatives which we have already calculated. We divide it by n, and we should get just function of x only. It means there should not be any y. In that case, integrating factor will be e raised to integration f of x dx. So let us go for the second rule. The second rule is del by n by del by x minus del by m by del by y upon m. So you can easily see there is a very small difference, right? Simply we interchange those partial derivatives, we replace m by n by m here. But the major difference is here we should get just function of y only. It means there should not be any x. In that case, integrating factor will be e raised to integration f of y dy. So I told you first 2 rules, 2 more rules are there. The third rule is the given differential equation should be in this form. So it should look like this. Getting? It should look like this. Y we have written outside, f1 of xy, there should be some function of x and y. Function of xy, not x and y, xy. Getting? It means xy, xy, xy should appear everywhere. X outside, function of xy, 0. Okay, and one more condition is there. So if those conditions will satisfy, then we can go for rule number 3. And the last rule, the function should be homogeneous. Homogeneous, that means degree of each term, power of each term must be same. Get it? So generally I suggest go for rule number 3 and 4 first, since it is very easy to check whether rule number 3 and 4 are applicable or not. If both rules are not applicable, then only we go for rule number 1 and 2. So they take more time to solve. Okay, so generally I suggest you to go for rule number 3 and 4. So 4, let us check. Power is same, no powers are different. Combined power, huh? If we have the product, we take the combined power. 2 plus 2, 4. Power is not 1 plus 1, getting, so having a different powers. So that means definitely the rule number 4 is not applicable here. Let us check rule number 3. Y outside. Yes, fortunately we have y outside. F1 xy, getting xy, everywhere xy. Here also x square y square, having the same power, right? X outside, xy, xy again, getting, so that means the rule number 3, I feel that the rule number 3 is applicable here. But see, as I told you earlier, there is one more condition. So let us check that second conditions will be satisfied or not. Okay, so let me write clearly. Just remove this part. Okay, so we have this space, let us use. So given differential equation is in the form y f1 of xy dx plus x f2 of xy dy is equal to 0. It means the given differential equation in this form, right? But see, as I told you, one more condition is there. So let us check that second condition will be satisfied or not. Second condition is mx minus ny should be non-zero. Let us check m. Where is my m? This m, and we are multiplying by x. So x, m is y plus xy square plus x square y cube, right? Minus ny. Y I have written first, n is here. X minus x square y plus x cube y square, right? So let us simplify the brackets. We'll take the product. X into y, xy plus x into this one, x square y square, x into that one, x cube y cube. See, when you have minus sign outside and when we solve the bracket, sign will get changed. So y into x, xy minus minus plus x square y square minus plus minus x cube y cube. So tell me, can we cancel anything here? Definitely this xy will get cancelled with minus xy. X cube y cube will get cancelled with minus x cube y cube. Okay, so just two terms are remaining, x square y square, x square y square. Sum is 2x square y square and it is non-zero. It means the second condition is also satisfied. So we can ready to apply rule number 3 to find integrating factor. So let me tell you what will be the integrating factor. The integrating factor is 1 upon mx minus ny. That means the same which we have calculated just now. Just it is in denominator. So 2x square y square. So finally we got the integrating factor. It means if you multiply given differential equation by this integrating factor, this non-exact differential equation will be converted into exact differential equation. Okay, so let me clearly mention multiplying given differential equation by 1 upon 2x square y square. Okay, so see, I am going to multiply, but as you can see here, 1 upon it means that term is in denominator. So when you multiply to all sides of this given differential equation, obviously that 2x square y square will appear in denominator. Okay, but see, right now there is no more space to write. Make a screenshot of it first, then I will move further. So I have divided the given differential equation by that 2x square y square. Okay, see now tell me, can we cancel anything? Yes, this y will get cancelled. Here x we can cancel. Okay, so after that what will I do? I will divide separately. Let us see what will happen if I divide separately. 1 upon 2x square y plus xy upon 2x square y plus x square y square upon 2x square y dx. Here also I will divide separately. Okay. 1 upon 2xy square minus xy upon 2xy square plus x square y square upon 2x y square dy is equal to 0. Okay, so I have divided separately. So let us cancel out the terms. Okay, what can we cancel here? X, 1x will get cancelled, y will get cancelled, x square will get cancelled, 1y will get cancelled, x, 1y, y square, 1x. So let me write the remaining terms. 1 upon 2x square y plus 1 upon 2x plus y by 2 dx. Let us see what will happen here. 1 upon 2xy square minus 1 upon y is there in denominator plus x is there at numerator and by 2 dy is equal to 0. Okay, so finally we got this differential equation. So initially the given differential equation was non-exact. By multiplying integrating factor, we converted into exact. It means this differential equation is an exact differential equation. Let me clearly mention, this is an exact differential equation, right? So let me write new m. So this is m, which is multiple of dx, 1 upon 2x square y plus 1 upon 2x plus y by 2. And what is our n? This multiple of dy is our n, 1 upon 2xy square minus 1 upon 2y plus x by 2. So finally we got that exact differential equation and m and n also. Now the question is, what will be the solution? The solution is integration m dx by treating y constant and integration terms of n free from x dy is equal to c. This will be the solution. Okay, so when you have exact differential equation, we have a fixed formula to calculate its solution. See, it is simply the addition of two integrals. So what will I do? I will solve this two integrations separately. We will add and we will write is equal to c. That will be the answer. Okay, so let us start. So consider integration m treating y constant with respect to x, right? So as you can see here, m, this is our m. But see, addition is there, three terms are there, first, second, third, additions are there, getting? So that's why we can take separate integrations. So let me write directly 1 upon 2x square y dx, 1 upon 2x dx plus y by 2 dx. Okay. After that, what will I do? Whatever the constants, I will take them outside. Okay. So will you tell me what will be the constants here? Yeah, you can easily see constant means numbers, as well as y is also constant. That means functions of y are also constant. You can take them outside. Let us use this space to solve the remaining part of this problem. Okay. So 2y, 1 by 2y, that is a constant. So inside we have 1 by x square, 1 by x square. Okay, dx is there. But instead of writing 1 by x square, I will write x raised to minus 2 dx, having a same meaning. 1 by x square, that means if you shift at the numerator, you will have x raised to minus 2. But see why I am writing in this way? Since it will be easy to apply the formula. That's why I am writing in that way. 1 by 2 is constant, will come outside. So 1 by 2 integration 1 by x dx. And here, yes, right. Here y is also constant, 2 is also constant. Let us take them outside. So y by 2 integration dx. So this is equal to 1 by 2y. So now the question is how to find its integration. Okay, so it has very simple formula. Integration of x raised to n is x raised to n plus 1 upon n plus 1. So in case of derivative, what we do? We reduce the power by 1, but here we increase the power by 1. The power is minus 2. If you increase it by 1, minus 2 plus 1, it will be minus 1. So that's why the integration will be x raised to minus 1 and the same number in denominator minus 1, just like this, plus 1 by 2. Integration of 1 by x is log x. Integration of what? 1 by x is log x. Plus y by 2. Integration of dx is x. Okay. So let me write in a more proper way. So see, the minus sign is there. I'm writing here 1 upon 2y. You can see x raised to minus 1. The power of x is negative. Okay, actually the answer is x raised to minus 1. But see what I'm doing, I'm shifting to the denominator. Then the power will be positive. I'm shifting to the denominator. So you will have x here. Getting x here. Plus 1 by 2 log x. Let us take the product xy by 2. That's it. Finish. So I got the value of first integral. But see, wait, there is one more integral. Let us solve. Now, integration terms in n free from x dy. Terms in n. N. Where is my n? This is my n. How many terms are there? 3 terms are there. First, second, third. But we want a term which is free from x. That means there should not be any x. In first term there is x. We cannot take. In second term there is no any x. It means we can take it. In third term there is again x. So you cannot take. So we have to consider just second term only, minus 1 by 2y dy. Again I will do the same thing. Let us take constant outside, minus 1 by 2. Integration 1 by y dy. So integration of 1 by y is log y. It means minus 1 by 2 log y. So see, what will be the solution? Solution is nothing but addition of these two integrals and is equal to c. I am repeating. Whatever the integrations we have solved, so what will be the solution? Solution means simply addition of these two integrals and is equal to c, we write. Okay. So just make a screenshot of it. I'm going to write the answer directly. So I have simply added the values of two integrals. I got this one. But see, here we have a two terms of log. So let us do something with them. So minus 1 by 2x. You can keep as it is also. Here if you declare this is the final answer, no problem. That will be the answer. But see, I'm simplifying it more. So 1 by 2 we can take outside common. So inside the bracket we have log x minus y, log y. Do you know this property of log? Log a minus log b, which is log a upon b. So therefore minus 1 by 2 xy plus xy by 2 plus 1 by 2 log x upon y. This is property of log. Log a minus log b is equal to log a upon b. So this is the final answer we got. We can simplify it more also, but that is enough. Here also you can declare this is the final answer. See, now I am going to give you one problem for practice. You can try that problem on your own. If you have any difficulty or if you get the answer and if you want to cross check, you can watch my next video. In that video, I am going to cover its solution. Just make a screenshot of it first, then I will give the problem. This is practice problem for you. You can try this problem on your own. Okay. Okay. So let us, if you want the solution, you can check in my next video. Okay. So we'll stop here. Thank you. See you in next video.